If there is no physical law or principle to help us formulate a model, we construct an empirical model, which is based entirely on collected data. We seek a curve that fits the data in the sense that it captures the basic trend of the data points. So for example number 2, a linear regression model. The table 1 lists the average carbon dioxide level here, measured in parts per million at Mauna Loa Observatory from 1980 to 2006. You're going to use the data in table 1 to find a model for the carbon dioxide level. Now, I'm going to show you 2 ways that you can figure this out. You can either use Desmos or the TI-8384 calculator. The first thing we're going to do is we're going to do that with Desmos. So I'm going to open up Desmos, and here's your graphing Desmos. Now, if you want to enter information on a data table, if you go up here to the where it says add an item, you're going to select that, and then down here it's going to select table. So when you have your table, you can go ahead and then put your data values of your table. So for example, we're starting at 1980. If I press enter, it goes, and then we go to 1982, which is what we want next, then it'll continue in terms of 2. But then individually you're going to have to put in the Y values. Okay, now I've already done that here in this graph, so I've already put in the data values from this data table. So if we look at the data table here, we have our years in the first column, and then the CO2 level is going to be in the second column. Now, what we've done is we've then created a scatter plot. Now, in order for me to be able to see the scatter plot, I need to make sure that my increments and zooming in on the correct place. So if I select this wrench up here, okay, I can come in here and I can change my x-axis to go from, let's say, since we started at 1980, we can say, okay, we'll start at 1975. And then we'll conclude, since we're finishing at 2006, we'll just go ahead and put 2007. So therefore, we can visibly see everything in this graph. And then on the y-axis, what we can do is, since we start at 338.7, it goes all the way to 381. My recommendation is just start at 0 and then go all the way to, let's say, 400. And so therefore, then you can see, the entire display in your grid. Now, you can scroll out of this, you can scroll up, it doesn't matter, whatever the case may be. But if you take a look here, as you scroll in and out, okay, you can see down here where it has the years, and then over here is going to represent what it's stated in the carbon dioxide level. So the next thing that we want to do is, we want to find the line of best fit for this model. Now, we can take a long time to pick out 2 points and find the slope of one of these lines and see which one that it best fits. Now, we could be sitting here all day to do that. Rather than doing that, what we can do is we can use the following function. So if we come up here where it says plus, we can go ahead and type an expression. So if you hit the Y button and then hit the 1, that's going to give you the Y element of the first column. And then if you look at the top part of your keyboard on the left, if you hit Shift, you're going to get that key right there. And then you're going to type in M, which is the slope, and then the first column, which is X, and then just type 1, and then add the Y-intercept, which is B. So now what happens is it gives you this information down below here. So let's go ahead and take a look at that. So I'm going to copy that in here. And so what that tells us is that our slope is given here. and this is our y-intercept. So what we've been able to do is we've been able to determine what is the function for this model. So it's going to be c, which is equal to mx plus b. So now that we know that our slope, we have 1.62319, and that's going to be x there, and then minus the y-intercept, which is minus 2876.2. Now, we can also take a look at the TI-84 or 83. So let's go ahead and pull that up. So in order for us to put this information, if we want to put this data, what we'd have to do is we'd have to go to see where it says stat, you'd click stat. And then here where it says edit, you're going to select enter. And then in the first column, you would then put in the years. And then in the second column, L2 is going to be the CO2 level. And then once you do that, the next step is we want to look at this in terms of a graph. So let's go ahead and select second and then the stat plot. And so up here, you want to make sure this says on. So in order for it to be on, since it's already on, you're going to hit enter. And then you're going to make sure that it says on. Right now, it's highlighted on, which is on. If I clicked enter, then it would be off. But we want this to be on. And then the type, well, you have these types of graphs. You want the very first one because that's a scatter plot. Then you select enter. And then the X list, meaning the X column is L1, the Y column is L2. And so now what we want to do is we want to be able to see, okay, what does this look like as a graph? So I'm going to go ahead and select zoom. And then down at the very bottom, we're going to select zoom stat and then hit enter. And then therefore you can see the graph. So now that we have our graph, what we want to do is we want to say, okay, well, I need to figure out what is the best fit line. So when you're using a TI-83 or 84, what you can do is you can go back to stat, and then here you're going to scroll to your right, which is calculate. And then we're going to go down all the way to number 4, which is linear regression. So we're going to go ahead and select 4. And then it's going to put it in the display, and then we're going to press enter. Now what it's going to do is, you see where it says y is equal to ax plus b. A represents the slope, and b represents the y-intercept. And you can see we get the same numbers. We get the slope is 1.623186 rounded to 9 there. And then we can see that the y-intercept is negative 2876.2. So you can either use Desmos or you can use your calculator to get that information. Now, the next thing we want to do is we want to say, okay, well, what does this look like when we put this line in? So what I mean by that is, okay, let's go ahead and then enter this into our calculator. So where it says y equals, we're going to put in this equation. So we're going to hit y equals, okay, and I'm going to put in 1.62319 x, and the x button is right here where it says, see the first letter is x, and then we're going to put minus and then 2876.2. Okay, now we're going to go back to graphing this. So we're going to select zoom and then go all the way to zoom stat. And then what it does now is it graphs that line to make that the line of best fit. Similarly, we can do the same thing on Desmos. So if we wanted to see what that graph looks like, we can put that in. So the graph that we want to put in is, let's see here, y, which is equal to 1.63, let's take a look at that number again, 62319x. and then minus, we have 2876.2. And now you can see that this line draws through those points. So what it does is it's the line of best fit for the data. So you can either choose to use Desmos to do this, or you can use the calculator, however way you want to go about that. And so ultimately, here is our graph that shows the line of best fit for this particular problem.